Good day, everyone, and welcome to today's webinar. Just wanted to give you a quick housekeeping items here. Everyone's mic should be muted, and that will remain that way until we get to the question and answer section. But feel free to leave a comment or ask your question. Chris Morris, our marketing manager, is the keeper of the questions, and at the end of the presentation today, we will have a time for some of your questions. So feel free to go ahead and use the chat function here today. So I just wanted to say before we get started, thank you very much for your time today. Everyone's time I know is very valuable, so I really appreciate you taking the time to be with us today. And I hope that the information that we're providing for you does pay some dividends for your time that you spent with us today. My name is David Cash. I am a technical application specialist here at Mountz, also a member of the marketing team. And I've been in the torque industry for about 20 years now. I've been with Mountz over 15 years. I've had a great opportunity to see a great number of unique and challenging applications, and that's what we do here at Mountz. Speaking of Mountz, Mountz was founded in 1955 in this garage here. We quickly moved to San Jose in the heart of Silicon Valley. We were also the very first company to develop an electronic torque tester for the military. We also have a warehouse, distribution, and service center located in Foley, Alabama on the Gulf Coast. So I would just like to say welcome, and let's go ahead and get into today's webinar. So we are discussing click wrenches versus CamOver wrenches, and hopefully with the information that you get today, you will leave with the information on knowing which tool may be best for your specific application. So as we get started here, we've got just a quick poll question that should pop up here on the screen. The question is, in your facility or your organization, which style of wrench do you predominantly use? Is it a CamOver wrench, a click wrench, a digital wrench, or even a breakover wrench? So we'll have just a few seconds here to go ahead and get that poll launched and answered, and then we'll go ahead and move on with the rest of the presentation. All right, let's see what our answers are here. Excellent. The overwhelming number there is click wrenches at 73%, followed by some CamOver wrenches, and then a few digital and a few breakover wrench. So thank you very much for that. And let's go ahead and jump into the session. So torque control, that's kind of what it's all about, especially when you're dealing with wrenches. And if we have great and really good torque control, then that really gets us to the means for the end, which we're really trying to accomplish, and that is getting the correct clamping force. Now, clamping force is very simple. You know, we have fasteners that are connecting components together. These fasteners all act like springs. They're holding the components together. As we tighten those down, the fasteners will begin to stretch. And if we can get the correct stretch on the fastener, then we're getting the right clamping force that we need. We'll talk a little bit more about what happens if we have too much clamp force and if we have not enough we'll touch on that here in just a second. But just a little bit on the history of the torque wrench. The first torque wrench was invented in 1918 by Conrad Barr. He worked for the New York City Municipal Water, and he was tired of their flange connections leaking and not being correctly tightened. So he developed a torque wrench to be able to help them make sure that they get all their fasteners correctly torqued. And since then, we've seen a number of different styles of wrenches. We have the standard click wrench. We also have beam or dial wrenches. There are digital wrenches, electronic wrenches. We even see split beam wrenches and even breakover wrenches as well. Now, the great thing about all of these wrenches is is that they do provide us a signal when the torque is reached. And that is a very good thing. There are some things that these wrenches don't do very well, and we'll talk about that as well. So when we look at what are the risks of using a specific type of torque wrench, and especially on critical type of fastenings, the wrench that is used can play a tremendous part on how the final torque is achieved. So when we're talking about our clamping force, if we have fasteners that are under torqued, obviously there's not going to be enough clamping force. This can cause the fasteners to vibrate loose, and then we have a failure. And then even maybe also worse would be the possibility of over torquing. If we put too much stress on the fastener, as it begins to stretch, it will come to a point where it can no longer be elastic, and it won't be able to hold the amount of force that's being put on it. And so any type of stress on that particular joint can cause the bolt or fastener to simply shear and break. So over torquing can cause a real problem, again, especially for very critical type of torquing applications. So when we look at the click wrench as a specific type of wrench that we're focusing on today, the click wrench is by far the most popular, the most economic wrench that we can use to try and have a good torque control. The click wrench is a very accurate wrench, and again, it will provide a good signal when torque is achieved. So if we take a look at this particular graphic, this is kind of a cutaway of what a more pivot block type of click wrench works. So we have a spring inside the tube of the wrench. As load is being applied to that wrench, that spring is compressed. And then there will be a moment where the pivot block that is there in the middle of the wrench in the gray box there will actually lift and pivot, and it will hit the inside wall of the torque wrench there, providing us with the click. Now that is great. As I mentioned, we are given the signal that we've hit the correct torque value. The problem with this particular wrench is that we only have a very small window to stop pulling on the wrench before we're adding additional torque to the assembly. That degree is right around 3 degrees of deflection once the wrench clicks. So that would be equivalent to driving down the road. You see a stop sign a little bit too late. By the time you hit the brakes and your car stops, you've already passed the stop sign and are now in the intersection where bad things can certainly happen. So this is how majority of the click wrenches work. There are some other wrenches like the split beam wrench that is more like a beam style wrench that will indicate when you've hit your torque. But again, there's nothing preventing the operator from adding additional torque to the assembly. And that's a real problem with all of the wrenches that I mentioned, either the click wrench, the beam wrench, the digital wrench. A lot of those particular styles of tools are great when they signal, but they don't help to prevent any type of over torque to the process. So this is basically an animation of the process of what can happen. So as the momentum of the wrench is being used, we have our click. If the wrench is not stopped in time, then we will have an over torque issue with the click wrench. If we'd like to look at this graphically, this is kind of how we would see it on a time versus torque curve. So we have our target torque, we have the point at where the wrench clicks, then we have our 3 degrees of deflection, and now we're adding additional torque to the process. So what's different about the CamOver tool is that the wrench itself will actually simply slip once we've hit the torque value. So this is an internally preset tool. It has a locking mechanism. There is no adjustable scale. There's no indication to the operator of what the value is set for that tool. So the wrench itself is set up, the torque value is locked, and then the operator simply uses that particular tool, and it will allow them to not only hit the torque value that's required, but it will also prevent them from adding any additional torque to the assembly process. The other nice thing about a CamOver wrench is that it's non-length dependent. So as we saw in the example of the click wrench, the pivot block, which is inside of the tube there, is actually our fulcrum point. So if an operator is holding the wrench in any other spot than what it is designed for with their hand, then you are basically changing the formula of the force times distance, and you are introducing another error to the process. So because the CamOver tool, the pivot point is on the end of the tool, we can hold that anywhere up and down the handle, and it's always going to produce the same amount of torque as it would if you were holding it anywhere else on the tool. So with that, here's an animation of how the click wrench works. So it simply cams over. We have a follower in there that will push onto the spring. Once the force has been achieved, then the follower then will slip into the next cam lobe, and the process will continue. So there is not a indication or a probability of the operator adding additional torque. If they try to come back and add it another pass or another hit, as it were, that you may see with some people that use a click wrench, they may double click it or sometimes triple click it. With the CamOver tool, you are not adding any additional torque. So I'll just go ahead and run that one more time so you can get another look at what's going on there with the cam mechanism. So again, as the follower pushes up the cam slope, we're generating the torque needed. Once it's reached the apex, it then will go ahead and seat down into the cam lobe, and we can start the process over again. So what that looks like graphically, just like the click wrench. However, with our time versus torque curve, again, we have a target torque, but because the wrench simply slips or cams over, we have the ability to be able to control not only the signal of when torque is achieved, but also not achieve any type of over torque to the fastener. So let's go ahead and take a look at a little demo setup that we have here. We have the torque analyzer, our Easy Torque 3 model, and then we also have one of our click style wrenches, and then also our new FGC CamOver tool. So if we look at what we're testing here, if we try to test the click wrench in what would be considered a peak mode on our analyzer, that is going to measure the highest peak torque available, or that is produced. So as I pull on the wrench, you can see the values that we're getting. However, this wrench is set to about 2.8 Newton meters. So now if I change the analyzer and I put it into the first peak mode, what this will do is this actually allows us to be able to see the value at where the wrench clicks. So in essence, it's seeing what the first peak is. It will also indicate what additional over torque we may see with this style of tool. So again, you can see that we're producing the click at the right amount at 2.8 or so Newton meters, but we are significantly producing over torque with the tool. So if I was an operator and just simply I was to double click, and you can see that I can add easily almost 2 times the amount of torque that is supposed to be for the application with the click wrench. So this is a very operator dependent tool. We can get it to work correctly if we simply are very cautious and very smooth, waiting for the click to happen, and we can certainly get good repeatable results with a click wrench. However, if demands on the production line are heavy, the operators may forego that and try to get work done as quickly as possible. And again, they have the possibility of introducing error into the assembly. So with the CamOver tool, I'll go ahead and set the analyzer back into the peak mode. And again, this is going to measure the highest peak torque that is available. There is an end cap on the back here. We set the torque with an Allen key, and then the locking mechanism inside here will hold that specific torque to us. But as I pull on the wrench, you can see that if I continue to go, I can't add any additional torque to the assembly. So in essence, I'm again with the curve and graph that we did show, you cannot go past the over torque value that you're trying to achieve with the CamOver tool. So is this specific tool needed in all applications? Absolutely not. But if you do have a critical torque application, you need to be able to have confidence in knowing that this particular tool will help to error-proof your assembly, that you're going to be getting the correct torque every time. Then the CamOver tool is going to be the preferred method for tightening. So at this point, we can move into questions and answers. If you've gotten anything available here, Chris.
All right, Dave, first question. When you mentioned over torque on a digital wrench and on the screen it shows the torque, how do you know it's over torquing?
Again, there's with a static type of wrench, there is no mechanism on the wrench itself to either break away or preventing the operator from still pulling on the wrench. With a digital wrench, you are going to be pulling that. Once the wrench indicates that it's time to stop, you actually physically have to stop before you add any additional over torque.
All right, next question. If you're using a click wrench, is there a means to way to audit the torque after you tighten down a bolt or a fastener?
Yes, there's a number of different ways that you can audit a fastener. You can do either a line test or a breakaway test where you would mark the fastener. You can then break the fastener free, bring it back to that line using a dial type of wrench or even a digital wrench, and then see what that torque value is. You could do a first movement test using a specific auditing wrench that is primarily a digital tool where you can set the tool, if it has angle capabilities, to just read the first movement of the fastener. So we're moving it again in the tightening position. And then we want the wrench just to tell us within the first few degrees of movement what that torque value is. So we do have that ability to check it. You could also use a CamOver style tool to check it if you are concerned as well that you may be under torquing a fastener. That's possible as well.
Thanks, Dave. Next question is, what's the accuracy of a CamOver tool versus a click type wrench?
The accuracy falls within the same parameters as a click wrench with the ISO 6789 specification. The CamOver tools, however, are going to produce a much more accurate result, a much more repeatable result than you would with a click wrench. With our series of FGC, we are guaranteeing that you can go twice the recommended calibration cycle for an ISO 6789 tool to 10,000 cycles. We're also really confident with this wrench that we're offering a 2-year warranty on it and also a lifetime warranty on the tool for any type of manufacturing defect as well. So the CamOver style tools are very accurate, very repeatable, and will give you much better result than a click wrench.
Thanks, Dave. Next question is, what is the reference standard used for each type of tool?
What is the, I'm sorry?
The reference standard that you had mentioned?
The ISO 6789 7 or 12017, I believe, is the spec for that. There's also the ASME spec in there as well.
Okay. Next question is, what kind of price difference is it typically between a click wrench versus a cam wrench?
The CamOver tool, because of its build and its materials, it's going to be more expensive than a click wrench. It could be in the ballparks of around 4 to 6 times more expensive. However, if you just had one component in rework that you had to go and you had to fix, you had to pull parts, the labor involved, with being able to control the amount of torque that's being given, the ROI on a CamOver tool is very easily justified.
Okay, thanks, Dave. And it looks like that's the last of the questions.
All right. Well, thank you so much for everyone that has attended. And if you have any other questions, feel free to contact us at Mountz. We'll be happy to go ahead and give you some more information that you might need.